how to calculate the shear force and bending moment for a simply supported beam. Let us consider a simply supported beam AB of span 10 meter carrying a point load 10 kilonewton at a distance of 1 meter from B and 2 kilonewton per meter UDL at a distance of 3 meter from B and 20 kilonewton at a distance of 3 meter from A. For simply supported beam, we want to calculate the end support reaction RB and RA. First of all, taking moment at A. As we know that for point load, we have to consider the load into distance, and for UDL, we have to consider the load into distance by 2. Therefore, I am taking moment at A from end B. Therefore, RB into the total distance 10. Then the support reaction RB is acting upward, therefore the sign is positive, plus. For C point, the point load 10 kilonewton is acting downward, therefore the sign is negative. For point load, we have to consider load into distance, therefore minus 10 into the total distance from C to A is 9. Minus, then for UDL, we have to consider load into distance by 2, therefore load 2, distance 2. For 2 into distance by 2, 2 by 2. Then we have to consider the distance from E to A also, therefore plus 5. Then again minus, because the load 20 kilonewton is acting downward, therefore we are using the negative sign, minus 20 into the distance from F to A is 3 equal to 0. Then solving 10 RB minus 10 into 9, 90 minus 2 into 2 by 2 plus 5, the value is 24 minus 60. From that we calculate RB equal to 17.4 kilonewton. Now we get the value for the support reaction RB. After that we are going to calculate the summation of upward force equal to summation of downward force. The total upward force is RA and RB. Therefore, RA plus RB equal to downward force 20 kilonewton and 10 kilonewton are point load. Therefore, we are considering the load at that point only. For UDL, we have to consider load into distance. Therefore, 2 into 2. From that, we get the value for RA. RA equal to 16.6 kilonewton. Then we are going to calculate the shear force. I am going to consider the shear force from right side. Therefore, from right side, FB right, the value is 0. For point load, we have to consider the point load at that point for left side only. Therefore, for right side, the value is 0. For left side, FB right, the RB upward force is acting. For upward, while considering shear force from right side, upward we have to take the negative sign. Therefore, FB left minus RB. The value for RB is 17.4 kilonewton. Therefore, minus 17.4 kilonewton. Then FC right, the point load at that point we have to consider for left side only. Therefore, for FC right, the value remains same as FB left. Therefore, minus 17.4. For FC left, we have to consider the point load at that point also. Therefore, minus 17.4 plus 10 equal to minus 7.4. FD right, the same value for FC left, minus 7.4. For FE right, minus 7.4 plus UDL load. For calculating UDL, you have to consider load into distance. Therefore, 2 into 2. The value is minus 3.4 kilonewton. For FF right, the value remains same, minus 3.4 kilonewton. For FF left, minus 3.4 plus 20 equal to 16.6 kilonewton. For FA right, 16.6 minus upward force RA. The value for RA is 16.6, therefore the value remains 0. FA right, the value remains same as FF left. For FA left, we have to consider the reaction at A also, therefore 16.6 minus 16.6, the value remains 0. After that, we are going to draw the shear force diagram. First, for RB, the value is FB right value 0, FB left value negative. Therefore, you have to draw below the axis line, therefore minus 17.4. For FC right also, the value remains same, therefore 17.4. You have to extend the line. from B to C. For FC lift, the value is minus 7.4. Therefore, in the same line, we have to mark the minus 7.4 and extend the line from 17.4 to 7.4. For FD right also, the value remains same, minus 7.4. Therefore, you have to mark the point in the line of D. Therefore, minus 7.4. Then for FE right, the value is minus 3.4. Therefore, you have to mark the point in the E line, minus 3.4. The sign is negative. Therefore, you have to mark below the axis line. FE left, the value is also minus 3.4. Therefore, the same point. For FF right, the value is minus 3.4, and for FF left the value is plus 16.6. Therefore, above the axis line you have to mark the point 16.6. Then extend the line to FA right 16.6. Then for FA left the value remains 0. Therefore, it is at the axis point. While calculating bending moment for a simply supported beam, end moment is 0. Therefore, for B, MB value is 0. The moment at B value is 0. While calculating the bending moment, for point load, we have to consider load into distance, and for UDL, load into distance by 2. From the right side, we have to consider the upward force as positive and downward force as negative. Moment at B is 0. Moment at C, RB into 1. The RB force is acting upward, therefore the sign is positive. The value for RB is 17.4, therefore 17.4 into 1, the value is 17.4 kilonewton meter. Moment, the unit is kilonewton meter. Then for calculating the bending moment at D point, we have to consider the B point load and C point load. Therefore, RB into distance from B to D is 3. Therefore, 17.4 into 3. Then the point load 10 kilonewton is acting downward. Therefore, the sign is negative. Therefore, minus 10 into 2. MD equal to 17.4 into 3 minus 10 into 2 equal to 32.2 kilonewton meter. For calculating bending moment at E point from B, therefore, RB into distance from B to E is 5. Then the point load 10 kilonewton is acting downward, therefore the sign is negative, minus 10 into distance from C to E is 4. Then from ED, the UDL load is acting, therefore we have to consider load into distance by 2. The load value is 2. 2 into distance from E to D is 2, therefore 2 into distance by 2, 2 by 2. Therefore, moment at E value is 17.4 into 5 minus 10 into 4 minus 2 into 2 into 2 by 2. Value is 43 kilonewton meter. Then moment at F point from B. Therefore, RB into distance from B to F is 7. Then the point load 10 kilonewton is acting downward. Therefore, the sign is negative. Minus 10 into distance from C to F is 6. Then minus UDL is also acting downward. Therefore, negative sign, minus 2 into distance by 2. 2 into 2 by 2 plus the distance from E to F is 2. Therefore, moment at F point is 17.4 into 7 minus 10 into 6 minus 2 into 2 into 2 by 2 plus 2. The value is 49.8. Moment at A from B point. Therefore, RB is acting upward, sign is positive. RB into distance from B to A is total distance 10. Then C point, the point load is acting downward, therefore minus 10 into distance from C to A is 9. Then UDL is also acting downward, therefore minus 2 into distance, total UDL distance is 2 into 2 by 2 plus distance from E to A 5 minus the point load at F is acting downward, therefore negative sign, minus 20 into distance from F to A is 3. Moment at A point 17.4 into 10 minus 10 into 9 minus 2 into 2 into 2 by 2 plus 5. The distance from E to A point plus 5 minus 20 into 3. The value remains 0. As we know, for simply supported beam, both the end moment value becomes 0. If the value remains 0, then the problem is right. After calculating the bending moment, we have to draw the bending moment diagram. Here all the moment values remains positive. Therefore, all points we have to mark above the axis line. MB the value is 0. Therefore, we have to mark on the axis line. Then for MC the value is plus 17.4. Therefore, for positive we have to mark above the axis line 17.4. Then for MD 32.2. For ME 43, MF 49.8 and for MA the value remains 0. The value is gradually increasing, therefore the line come like this. This is the procedure for drawing the shear force and bending moment diagram for a simply supported beam. Thank you.